Okay, so welcome to another GroovyDSP tutorial. We're going to talk about a kind of oscillator I'm partial to. It's controls that kind of aliasing fold over in a way that I feel like is intuitive and easy to understand, or relatively easy to understand. And this is called a transition splice oscillator. And what you do is you take, let's say you have a saw wave, or let's say a square wave, because this is what we're going to start with. We're going to deal with this case first. And you have these jaggy jumps in here. And this is what's going to be causing a lot of your aliasing, is the power kind of in here. And what you want to do is you want to replace this with a jump that is already kind of band limited. So it's going to look like that now. So you draw your square wave normally, except now what you have is you have a little band limited transition, and this preserves a lot of the highs while minimizing a lot of the aliasing noise. And so how do you get that step? Well, we know that a square wave has a step like that, right? So and we know what harmonics make that up. So what we can do is we can generate a square wave. Here's my one cycle of a band limited square wave. And what we can do is we can just kind of harvest the part that we want, right? And in fact, we're going to need two steps for this. We're going to need one going down and one going up. So in my table, in my program, I have your square wave going this way and then going this way. The wiggles imply that it's made of sine waves, like in the previous tutorial I put up. And you should go watch that if you're unclear here. So we're going to have two different transitions. So if you're going from high to low, you're going to splice this in. And if you're going from low to high, you're going to splice that in. Now, one thing is that you don't need that much of a splice. And the more splice you have, the more it's going to sound dull. So you only need about 4 samples worth of transition. And you're going to pick the 4 samples out of here that align with your kind of current position. So let's maybe go over to the code and I'll explain how this all works. Okay, so here's my kind of tutorial code for producing this square wave that is a bit more band limited than your naive square. We have this transition table or splice table. It's going to contain that square wave cycle that we're going to splice in half of the time to provide those nice transitions. And it's going to be, this one's going to be 2,000 samples long, because I'm not going to interpolate. We're just going to pick samples out of it. So we're going to generate this, and what you're going to see is we're going to generate 2 harmonics of this square wave. And that's enough for that 4 samples, because you can only fit 2 harmonics into 4 samples of transition. And I went over that in the last video as well, why that is. And then we normalize it. We amplify and center the waveform. And then I write it out for future reference so I can look at it. So let's look at it real quick, because why not? So here's our table here. So here's ramping from up to down and down to up. We're going to splice this in when needed. And yeah, it doesn't look much like a square wave because only 2 harmonics of that square wave, which is pretty dull. But once you speed up to 4 samples, you'll see what happens. So get that out of the way. Okay. So what we want to do now is we're going to calculate the oscillator. And we have, as usual, we have the position, pause. We have the step length, which is going to be 2 times our delta. And the step length is set like this. Think of it like this. From 0 to 1, what is the proportion of that wave cycle taken up by our step, by our transition splice? And that'll get you this answer. And this is useful because this 0 to 1 measurement is what we use for the oscillator's position. And so we want to look at the position and see whether we are in this transition splice zone. only it's really supposed to be delta times 4 if you want a 4-sample transition. This is a slightly different version of the code we're looking at. Okay, so if you're in the first half, you splice in the first half of the table. If you're going to the second half of the square wave, you splice in the other half. And you only do this if you're within this kind of step threshold here. And otherwise, what you're putting on is just a flat line. So this is going to be the end of your square wave step, so it matches up with the table. So you don't have any jumps there. And if you're in the second half, you kind of repeat the first part of the table. So over here, yeah, you have your usual delta increment. Okay, and so that'll do it. And let's listen to this. Let's see how this all sounds. So we're gonna do, let's hear the non-band limited first. So to remind you what this looks like. Whoa, this is ugly. Oh, no. The non-band limited square. Let's here, center this and everything. Okay, non-band limited square is going to sound like this. It's horrible. Okay, let's load the band limited one that we made, and I'll show you the. Okay, so here's our band limited square, and this uses that 4-sample splice, and you can see it over here. 1, 2, 3, 4. Well, one of these is going to be hard to tell that it's deviating from the flat part, but these are 4 samples, and you'll see there's very little aliasing in this as it gets higher and higher. And one really important thing, it's not just splicing the same 4 samples in every time. It depends where it is in that transition zone. Depends where it's pulling the samples out of the table. So let's hear this and see how it all sounds. Right? Check that out. That's almost no aliasing. That's pretty incredible, really. So this is the original transition splice example that comes with Pure Data. It was made by Miller Puckett, who also made Pure Data. And Pure Data, by the way, comes with, it's a visual programming language for audio that comes with so many great examples like this. But anyway, I've taken this and I've modified it a little bit. We've already gone over the square wave adaptation of this that I made. This is the original that just makes a saw wave. And this looks pretty complicated, but the important thing to look at here are these 2 parts. So instead of splicing in the way I did, where I stop producing the square wave, or in this case the saw wave, and instead cut to a splice and then resume, this does something a little bit more clever, to be honest. You subtract these 2 signals from each other and you wind up with this. So let's explain here. This is just that band limited stair step like you saw in my example. And in fact, we can go in here, look at the transition table. Well, I'm in edit mode. Here we go. Move that on here, and you can see it looks just like mine. Okay. With the exception that theirs is only 1/2. We're only going one way because it's a saw wave, right? You're only going a low to high, and then it ramps up and then drops again. That's a saw. So we don't need both halves. That's the one big difference. But the shape is generally the same. So anyway, this is low, 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 and then you have right over here. You've got your band limited step, and then it resumes as a flat line. And what you want to do, the reason you subtract, is you see this discontinuity that's going to produce all the aliasing. And this graph here is just a naive saw wave like we made in that really nasty sounding first oscillator tutorial. When you subtract these 2, these cancel. And you've noticed that this band limited hump is in the middle of the cycle. right? So you look at where the phase lines up. This is the discontinuity, cancels. You can see it canceling right there. It's a straight line. And instead, where this is spliced in, or added in, is where this hits, around where this hits 0. And you get this nice jump, band-limited jump in the middle that's not aliased and continues. And it sounds really good. I have a recording of it right here. Check this out. One thing you can do too is, if you don't like my technique and you like this one better, I like the way it sounds better, what you can do is you can always take two saw waves and you subtract them from each other, and that gets you a square wave. What you do is you offset the phase a little bit, and the amount that they're offset from each other, you get that pulse width modulation that sounds really cool, and you can control it that way. I can show that in a different tutorial at some point. Let's summarize here. So why I dig transition splice oscillators. They are relatively clean sounding. They don't have that nasty aliasing you heard in the naive version of the oscillator. They are relatively intuitive. That means you don't really need a knowledge of filters, of digital filters, to implement this and to understand why it works, which I think is great. It supports pulse width modulation and hard sync, and not every technique to reduce aliasing in oscillators supports these. So you can make really animated sounding analog style synthesizer patches with this. It is light on the CPU as long as you can handle a couple branches. Miller Puckett's version that I showed is more DSP-ish, if that fits better with your code. I like my style a lot because it's so light on the math. And that pretty much sums it up. It's not a bad basis for your next synth project. Thanks for watching, and if you have any questions, leave them in comments, and I love answering questions and doing videos, so let me know, give me feedback. I'll see you next time.